Hi everyone, this is Shaila, Assistant Professor, Department of Mathematics, SNS College of Engineering. Today I am here with the continuation of the previous videos. We started with testing of hypothesis and we saw large sample test, Z test, and then small sample we started with D test. In D test we saw single mean. Now I am here to present difference of mean. Already we have seen notations that we use. Directly I am moving on to the problem. Here I have considered a problem. Two Indian samples are chosen from two schools A and B. A common test is given in a subject, the scores of the students. So common test for two sets of data, school A and school B, a common test marks is taken. Can we conclude that the students of the school A performed better than student of B? No doubt here, you need to check whether school A performs better than school B. First, calculation of all data, I am writing with starting with H0, H1. Here it is comparison of two data. So here mu1 equal to mu2. When you come for H1, they are asked saying that H1 is better perform. So better perform means it should be greater than. So you are taking it as mu1 is greater than mu2, which becomes one tail right. Now alpha, since no level of significance is given, you take it to be 5%. Degrees of freedom, here calculation of degrees of freedom is n1 plus n2 minus 2. So it is 7 plus 8 minus 2, it is 13. For that, for degrees of alpha 5%, for 13, your t-test value is 1.771. So these data are being taken. Now, from the data given, as you saw in single mean, you have to find out what is x1 bar, x2 bar. So x1 bar, as you all know, it is average. So summation of all x values divided by number of terms, value is given here. x2 is summation of all x2 values divided by number of terms, it is 8, so it is 62.6. So I have calculated x1 bar and x2 bar. From these two, you know that you have to calculate variance, which is s square. Since we have two set of data, I am calculating s1 square and s2 square. You know the formula already, we have seen in single mean, it is summation of x1 square divided by n1 minus x1 bar square. Substituting, I have got it to be 355.14. Similarly, s2 square, second set of data, so I am replacing the formula for x2 and I have got the answer as 503.37. So I have two set of variance. To make it as simple as, your formula is n1 s1 square plus n2 s2 square divided by n1 plus n2 minus 2. So I am getting a square value. So all these data are ready. Now we are testing hypothesis. T formula is x1 bar minus x2 bar divided by square root of s square of 1 by n1 plus 1 by n2. All the data values substituted over here, you get the answer. The answer is 0.173. As similar to the previous test, your conclusion is your calculated value should be less than table value. Here your calculated value is 0.173, table value is 1.771. It seems to be calculated value is less than table value. So H0 is accepted. In all this test, we see only the acceptance of the test. Moving on to the next test, it is your F test. T test, if you see, it is testing of mean. F test is testing of variance. So here, more or less, it is going to be similar. We know the variance formula. So until variance, it is going to be the same. Only the test statistics is going to change. To make it simple, I have taken a question. In one sample of 10 observations, the sum of the squares of deviation. When you say sum of squares of deviation means x1 minus x1 bar the whole square. That is sum of squares of deviation. So it is directly being given. For a sample of 10 observations, it is 314. Test whether this difference is significant. So here we are taking two samples. The samples are n1 is 10 and n2 is 12. As it is given, the sum of squares of deviations are given to be 120 and 314. So summation of x1 minus x1 bar the whole square is 120. x2 minus x2 bar the whole square is 314. So from that I have already told you it is calculating variance. So I have calculated s1 square and s2 square. Your answer is here. When you see this, s2 square is greater than s1 square. So that should be taken to the numerator. Now moving on to your h0 and h1. Since it is variance, we go with sigma 1 square and sigma 2 square. So h0 is sigma 1 square equal to sigma 2 square. h1 is sigma 1 square not equal to sigma 2 square. When you go for degrees of freedom, same rule. Since nothing is given, I have taken it to be 5%. When you go for degrees of freedom, numerator value s2 squares sample size should be taken. So it is n2 minus 1, it is 11. For denominator, it is n1 minus 1, it is 9. So when you see for table value, you have to see for 11, 9. Numerator 11, denominator it is 9. So your table value is 3.11. Now your test statistics F is s2 square divided by s1 square. I have both the values, substituting, I have got it. So your conclusion is going to be as similar. Calculated value should be less than table value. Here when you see your calculated value is 311, table value is 2.14. Obviously it is less than, therefore H0 is accepted. Thank you.